Imagine that you have a particle moving in a straight direction with this relation. The velocity is equal to v node minus ks, where v is the velocity, which is measured in meter per second. The s is the distance from a certain point, and it is this position or distance is measured in meter, and k is a constant. The requirement is to find s in terms of t, of time, and a, acceleration, in terms of time also. So you can notice that the velocity is a function of distance, where v is equal to v of s. So this is pretty easy, and we can also, from the kinematics, we know that the velocity is actually the differentiation of position, ds by dt. To find the distance, we cannot integrate the velocity with respect to time, because the velocity is not a function of time. It's actually a function of distance or position. So what we'll do, we know that we can, using integration and using separation of variables, we know that we can take all the variables of time in one side and the variables of position in the other side. So we can say that dt is equal to 1 over v of s ds. Now we can integrate both sides. So we shall integrate this with respect to time, and integrate this with respect to s. There was another given also, which says at position 0, time is 0, or at time 0, position is 0. So this is given actually in the problem. So we can integrate this by putting the limits to be the time to be first 0, and so that the position would be also 0 initially. So till it reaches t, and this till it reaches s. Those are the limits of the integration. Now we can integrate both sides to get time, of course t minus 0, and this we shall integrate it. So first of all, we shall replace v of s with v node minus ks. So v node minus ks ds. So the integration of this is actually ln, or logarithmic natural logarithmic function, which is ln of v node minus ks over negative k. So this is using that chain rule. So yeah, or this is so we differentiated first, we integrated all the term, and then we took the negative k here. So this is actually a very basic thing, but it is evaluated from 0 to s. So we shall put this here, multiplied by, we shall replace the s with s, and in the next time with 0, and subtract both values. So actually we'll have v node minus ks over v node. We know that ln minus another ln is ln the first value over the second value. It's a property for logarithmic functions. So yeah, we can take the negative 1 over k in the other side, or multiply both sides by negative k. So we'll have negative kt equal to ln v node minus ks over v node. So let me remove these absolute signs and make it a bracket. So we know that ln is actually the log with base e for the same function. So e power this value is equal to that value. So e power negative kt is equal to v node minus ks over v node. So to get s in a side with itself, we shall multiply v node with this exponential function, and also put it in the other side, and also v node will go to the other side, or remain in this side, and the s will be here. So actually s will be equal 1 over k times v node minus v node times e power negative kt. You can see that this is actually s of t. So we got it in a very easy way. And then we need to find a of t. So we know that to get a of t, we know that a of t is actually dv by dt, and we know that v is actually ds by dt. So let's work on this to find the acceleration. So first of all, to get a, we need to get v in terms of t, in terms of time. The problem is in the initially we had the velocity in terms of s. Now we will have it in terms of t. So v of t is equal to ds by dt, which is the differentiation of this. So 1 over k, I shall take the v node as a common factor here. So here we will have a 1, which is a constant, and its differentiation is 0 actually. So, and we have here a negative, so we will differentiate this to get positive, so negative times negative, and k times e power negative kt. The k goes with the k, so we will have v node times e power negative kt. So this is the velocity in terms of time, of course. And then we can get the acceleration as a function of time by differentiating this again. So we'll get negative k times v node times e power negative kt, and that's it. So now we have the distance or the position as a function of time, and we have also the acceleration as a function of time. Thank you.